Hey, hello there. Let's talk about today's Leetcode challenge question, 3-sum. So we have an array of n integers. We want to choose 3 elements from this array, A, B, C, such that they sum up to 0. And we are interested in finding all the unique triplets in the array that satisfy this condition. So looking at the example, we have this array with 6 integers that are -4, 2 copies of -1, 0, 1, and 2. So the triplets that satisfy the condition are, we have 2 of those, -1, 0, and 1. So indeed, -1 and 1, they sum up to 0, 0 and 0, they sum up to 0. -1, -1, these two sum up to -2. That's on the negative side. On the positive side, we have a single 2, so those two add up to 0. So these are the, so we just verify that these two indeed sum up to 0, that satisfy this condition. So yeah, that's pretty much the question and the example. So to solve this very brute forcefully, we can do a triple loop, right? So for A, for B, and for C. And then we do a simple test whether sum of A, B, C equal to 0. If that's the case, we push this combination onto some kind of container. And in the end, we just return all the possible triplets we find using this brute force solution. So the time complexity for this is obvious that we try all the possible 3 number combinations. So it's going to be in the cubic time territory. And the problem with this, when you look at it, is that the choice of A, B, C are pretty much independent here. So even though you have already made a choice about A, that doesn't affect how you choose B and C. But that's not really the case, because we have this relationship between A, B, and C. So with this relationship, A plus B plus C has to be equal to 0. We can just move A over to the other side. You can see that once we fix A, made a choice about the number for A, B and C, it's reduced to a 2-sum problem. So we're looking for 2 numbers from the remainder array that sum up to negative of A. So we know that there are linear time algorithms to solve the 2-sum, to use a hash map if the array is not sorted. If the array is sorted, we can use 2 pointers. So if we use that linear time 2-sum function helper, then we can reduce this to square time. So we're just going to make a choice about A and try to find the 2 number from the remainder array that sum up to the negative side of A. So that's pretty much the big idea. We're just going to try all the A. When we make a choice about A, we invoke this 2-sum subroutine to find B and C. Note that now, because our time complexity is upper bounded by, it's now square time. So we can actually afford to do sorting, n log n times sorting, because it's less than square. If we do sorting, we can use the 2-pointer 2-sum, so that we don't need a hash map that require a lot more extra space. So that's going to be my solution today. We're going to do a 2-sum using 2 pointers when the array is sorted. So let's code this thing up. Grab the number of numbers in this array, and we do some edge case handler here. If we don't have enough number, we return empty. Otherwise, we grab the number of elements, initialize the container to hold all the possible triplets. So let's actually call it triplets. And then we're gonna do is to do a loop over all the possible choice for A. We can do this in a while loop. So since that we must reserve two possible choices for B and C. This index for when we try to fix A cannot go beyond n minus 2. And also that based on this example, we can see if we want to sum three numbers to 0, the smallest number has to be negative, either 0 or negative. Otherwise, there's no chance the three number can sum up to 0. If we have three positive number, or the smallest number is a positive number, then there's no way we can sum up to 0. So we actually got some kind of filter on A as well. So A here is the i's number in this array. So the condition where we can still try to figure out the B and C is when the index is not the index for A allow us to choose two more number from this array, and also that the number we choose for A is a negative or is not a positive number. And then we're just gonna do the two-sum routine. So we can grab the target, which is the number that the B and C has to sum up to, which is essentially, which is just this, negative of A, and we do a two-sum. So it's gonna from we're gonna do the two-pointer version. So to do that, we actually sort the number, and we're gonna start with I plus 1 for the lower end, and on the higher end it's gonna be n minus 1. So this is gonna be I plus 1 and n minus 1 and the target. We're gonna code this function up here. Call this JK and target. So obviously here we want to do a loop while this two-pointer haven't met with each other, so they are still two different numbers. We want to do is to grab this B and C. And do test. If B plus C is larger than the target, that means we want to make the larger number smaller. So that's equivalent of saying we want to decrease K such that the number is smaller than C. And of course we don't want to have K to be less than J. The other condition is that if these two numbers sum up to be something that's smaller than the target, that means we want to increase the smaller number. The third possibility is that obvious B and C, they sum up indeed to the target. Then we find one of the triplets and we push it onto the triplets. So A is negative of target. So we just and once we do that, we need to make sure we don't do double counting. So we have essentially do this two thing here, which is to make the larger number smaller and make the smaller number larger, and see do we have another two number that actually sum up to this target. So that's pretty much the find two-sum subroutine that handles this two-sum. It's two-pointer J and K from the which is the leftmost and rightmost elements in the remainder array after we fix the A. And we're basically just going to try to move them towards the middle and try to find all the possible combinations for those two numbers that sum up to this target. So that's the subroutine that's been called here. Once we deal with this, we want to increment the I. The logic is similar to that. Yeah, so that's pretty much it. We do a sort. This is n log n time. We can afford to do this in the regular two sum. You wouldn't, if you want the linear time, you wouldn't do the sort. You use a hash map that requires more extra space. But since that we're looking at a square time upper bounded solution now, we can afford to do an n log n time to make the two sum constant space. Yeah, that's pretty much it. Let's try to run some examples. Do we collect all the possible? Yes, indeed. Okay, so it's accepted. So this is the three sum using a linear time constant space two sum subroutine, but it's assuming that the array is sorted so that we can use two pointer to find the combinations of numbers that sum up to the target. Yeah, so this is the question today.